Okay, hinge theorem. First thing that comes to mind when I see that word hinge is a door hinge, which is the connecting piece of a door that allows a door to swing open. So here's a door and it swings, and now there's the door. So where the hinge is located would be the vertex of an angle. So there's my angle. And the distance from where that door started to where it ended up is the opposite side of that angle. Okay, and we just kind of created a triangle there. So this brings me to the first thing we need to talk about in order to understand and do hinge theorem problems, which is identifying opposite sides. Identifying. I'm sorry, my handwriting is so bad. Let's try that again. Identifying. That's a little bit better. Opposite sides. Okay, so how do we identify opposite sides of a triangle? Let's say we have triangle ABC. Now I want to know which one of these sides is opposite angle A. So if we're talking about angle A, let's start there. Here's angle A. All you're going to do is draw an arrow, and wherever that arrow meets is the side that's opposite that angle. So same thing for C. Start at C, draw an arrow out. AB is opposite angle C. And there's angle B, draw an arrow out. AC is opposite angle B. Okay? The other thing is this notion that angles and their side opposites are corresponding. So more specifically, I kind of want to talk about clocks. Let's say I have here, kind of drew it a little bit off, but this is 3 o'clock. And let's call this 1 o'clock. Okay. 3 o'clock makes a 90-degree angle. While 1 o'clock, I'm not entirely sure what angle that makes, but I do know it's an acute angle. If you remember, acute means an angle that is less than 90 degrees. So that's the most important part. If we take a look at the 3 o'clock, the distance between the minute and the hour hand should be longer than the distance in the hour hand of 1 o'clock. And that should make sense. This is a bigger angle. 90 is bigger than any acute angle, since an acute angle is an angle that's less than 90. So therefore, that distance should be bigger than that distance. So we have everything we need now in order to solve these hinge theorem problems. So you will probably be asked to list the sides of a triangle from least to greatest, or from greatest to smallest, or you may just be asked what is the smallest angle, what is the largest angle. Either way, you're going to need to identify opposite sides in order for you to sort which one of these sides are smallest, which one's the largest, and you're going to use that using their angles that are opposite to it. So we have triangle DEF, and let's make angle D60. Let's make angle F40. Okay, and let's go ahead and say we want to list the sides from smallest to largest. All right, so first thing we should do is identify those opposite sides. So angle D, opposite side to angle D is EF. Angle F, the opposite side would be side DE, and angle E, that opposite side is DF. All right. In order to list from smallest to largest, I need to know what are my smallest angles so I can correspond that with my largest. What's my smallest angle so I can correspond that with my smallest side? What's my largest angle so I can correspond that with my larger side? Now I have 2 angle values here, but I'm missing one. And it's a good idea to go ahead and find this before we sort anything out, because we don't quite know yet if that number is going to be smaller than 40, which currently is the smallest number here, or if it's going to be larger than 60, which is currently the biggest number, or if it's going to fall somewhere between 60 and 40. So we're going to bring in another scale, which is the triangle angle sum theorem, which basically says that the three interior angles of a triangle add up to, that's right, add up to 180 degrees. Okay, so the three interior angles, so that would be angle D, angle E, and angle F, they add up to 180. All right, I know what D is, that's 60, so I'm going to plug in 60 there. I do not know what E is, that's what I'm actually trying to solve for, and F is 40. And they add up to 180. I have some like terms here, number terms. That is a positive 60 plus another 40. That's going to make 100. I'm going to drop that E. I'm solving for E, so that means I need to isolate it. That means I need to get rid of 100 by performing inverse operation. Since that's a positive 100, negative 100 would be the opposite. So E would equal 180 minus 100, which is 80. So E equals 80. All right, now I'm ready to sort. Turns out that 80 ends up being the biggest number of the three. So that means its opposite side is going to be bigger. But since they wanted it from smallest to largest, let's go ahead and do that. Let's see, smallest angle is F. So that means DE is my smallest side. Next up is 16. So that means EF is next up. And after 60 comes 80. That arrow goes down to DF. And that is the biggest side. All right, that's it for Hinge theorem. Here's one last look at the notes. And there you go.